All right, hello learners. Welcome to today's video. Now, on today's video, I'm going to be breaking down chapter 1 of elementary linear algebra, the 11th edition. That's the textbook we're going to be using, authored by Howard Anton. If you'd like to get a copy of that book, just send me a WhatsApp text using the number in the description section below this video, and I'll be more than happy to send it to you, the PDF form. Okay. So that's the textbook we're going to be using in conjunction with the UNISA study guide. At UNISA, they call this module the MAT 1503. But if you're registered with any institution, this video is still for you. It's relevant for you as long as you're doing first level linear algebra at any university institution in South Africa. Okay. But before we get into that, as per tradition on this channel, I'm going to give you an opportunity to subscribe to the channel if you haven't already. Then press the bell button so you'll be notified every time we post a new video. And lastly, press the like button, and you have the opportunity to do that right now. Right, so, okay, by the way, please remember that at the time of shooting this video, I'm still a student myself preparing to write the exam for this module, so none of this information is authoritative in the sense that, I'm preparing to write myself, so I've got an upcoming exam coming for this module, okay? However, I have consulted the textbook already mentioned, as well as Eunice's study guide, like I told you earlier, but I've tried my best to make this information as relevant as possible to all learners from any institution taking this module at first level. All right. Okay. Now let's get into the content. So this is my own personal summary of the important concepts that I think you need to know if you're going to be adequately prepared for the exam for this module. Okay. So chapter 1. This video deals only with chapter 1. Okay. So what do you need to know? You obviously need to know what a linear system is, and I'm going to be telling you the pages where you can get those. Like if you need more information, just use the search tool. Go to your files if you're using a mobile device or a PC. Go to your files, find the link, the reference material that we're using, in this case the textbook and the study guide, uh, and then just use the search tool to search any of these concepts if you find that you're unfamiliar with any of them. Okay, so the device is going to give you all instances of that concept, including the definition. So if you find that you're unfamiliar, you need more clarity, just search, type the term that you're unfamiliar with in the document, and the document is going to give you all instances of the term, including the definition, so you can you'll get better clarity there. Okay, so first off, we've got a linear system. You have to know what a linear system is, in particular a homogeneous system. Remember that a homogeneous system always has the trivial solution. What is a trivial solution? In simple terms, it's the one that's always equated to zero. Okay, so to learn more about that, just go to page 2 of the textbook. Okay, so you have to know what a homogeneous system is. You also have to know the difference between a solution set versus a general solution. So to get more clarity about the solution set, go to page 5 of the book, and the general solution is on page 13 of the book. Okay, but you can also consult the study guide. I think they are better represented there, because there's you just search general solution as well as solution set in the study guide, and they are well represented there. You'll get better clarity there. Okay, so you also have to know what a consistent system versus an inconsistent system. Those are on page 3 of the textbook. Okay, you also need to know, I think this one is probably the most important. What like about the elementary row operations? You'll find those on page 5 of the study guide. And look, even if you're not a UNISA student, the study guide will still help you. Trust me. It's got it's very clear, it's very simple, it's very basic. It's not too complicated. Okay. So you need to know about the three elementary row operations. You'll get that on page 7 of the book, as well as page 5 of the study guide. Remember, there's three here. I already told you about that. You also need to know about like what the difference between Gauss-Jordan elimination as well as Gaussian elimination. I hope I'm pronouncing those correctly. Remember this, that Gauss-Jordan elimination leads to reduced row echelon form. Okay, so you'll get that on page 15 of the textbook. While Gaussian elimination, on the other hand, leads to row echelon form, and you'll find that on page 11. So you have to know the difference between. They're actually quite similar. Just read, you'll see that for yourself. There's also generalized row echelon form. Yeah, they don't test it a lot from what I've seen, but you have to know it. You never know what might come up in the exam. Which sometimes it's simply called echelon form, as I discovered. You also need to know, of course, I already told you about the trivial as well as the non-trivial solution. You have to know the difference between those two. You also have to know, familiarize yourself with the multiplication of matrices. Remember that the multiplication of matrices is different from the addition and the subtraction thereof. Okay. The multiplication of matrices is quite complex. It's a quite complex procedure. It's not as simple as straightforward as the addition and subtraction thereof. With addition and subtraction, it's pretty basic. You just add or subtract the corresponding entries. Okay, not the case with multiplication. So you have to familiarize yourself with that procedure. Okay, just to look that up. Okay. There's also the transpose of a matrix. You find that on page 35. Remember that the transpose of a matrix looks something like this. You simply swap the column and the rows. So if you have something like this, so with the transpose, you simply swap the rows. So the first row becomes the first column, the first column that becomes the first row, and vice versa. So that's all there is. You also have to know, of course, the trace of a matrix. Now, what is the trace of a matrix? The trace of a matrix is simply the sum of all the entries in the main diagonal. What is the main diagonal? The main diagonal, of course, is it runs from top left down. Okay, so I'm gonna need to erase. As you can tell, there's not enough space to fit everything in there, and we've got quite a few stuff to fit in there. So I'm gonna have to erase. I hope you're taking that down as I'm writing. So those would be the trace of this matrix would be the sum of these three, 1, 5, and 8. So that would give you the trace of the matrix, the sum of 1, 5, and 8. 1 plus 5 plus 8. Okay, so that's the trace of a matrix. Um, and this is the notation we use for the trace of a matrix. It's a small letter A and subscript double I. Okay, that's the notation or the symbol that they use for the trace of a matrix. You also need to familiarize yourself with a linear combination. You'll find that on page 32 of the book. If you're hearing that term for the first time, just go look that up there. Page 32 of the book. You also need to familiarize yourself with the inverse of a matrix. I've never seen a paper that does not test you on the inverse of a matrix. So you'll find that on page 43 of the book, and as well as the method used to find it. That's on page 24 of the study guide. It's well represented there. So you want to go there and look that up, okay? There's also an invertible matrix. An invertible matrix is of necessity non-singular. You'll find that on page 43. So if it's invertible, you must know that it's non-singular. So if it's singular, that tells you that it's not invertible. Okay, it's non-invertible. It's non-invertible. Okay. There's also the properties of inverse matrices. I think you'll find that under the same page. Under just read on from page 43. You should find that there. There's also properties of the transpose. That's on page 48 of the book. Okay. Remember that I've consulted the study guide for the learning outcomes here for this module, for this chapter. Okay. So yeah, this is stuff that you really need to know according to the study guide. And yeah, there's also the rules and properties of matrix arithmetic. You'll find that on page 40 of the book. Remember that some rules that apply in algebra, they don't necessarily apply with matrices. Some do, but some don't. So you need to know that you can't make any assumptions. You also need to familiarize yourself with the identity matrix. Now, what is an identity matrix? Remember that an identity matrix has has ones, only ones along the main diagonal and zeros elsewhere. Remember that. So you must know that what an identity matrix is. Now, there's also, as a consequence of that, there's also the elementary matrix. Now, what is an elementary matrix? An elementary matrix is one that can be obtained from an identity matrix by performing only one of the elementary row operations. Remember, we said earlier there's three elementary row operations. So if you're given an identity matrix and you only perform one of those, the result is an elementary matrix. Okay. So you also need to familiarize yourself with the procedure on how to use row operations to find the inverse of a matrix. You'll find that on page 56 of the book. There's also row equivalent matrices. You need to know you need to know how to identify row equivalent matrices. You'll find that on page 53 of the book. You also need to, this one I haven't really grasped myself. I haven't really looked up. I just discovered it while drafting the summary. So I need to familiarize myself with it as well. How to recognize if the product of two matrices is defined or undefined. It's quite common. You'll see this a lot in a lot of papers, in a lot of past papers. So I've seen. So you need to familiarize yourself with that. as well as the addition and subtraction of matrices. I've already told you about that. So you need to also be able to solve a system of equations using the inverse of a matrix. Okay. So this one, I did try to find it in the textbook, but I couldn't, or the study guide. But yeah, I did a little digging and some research, and I think I'm well versed in this procedure now. If you need me to teach you, just send me a WhatsApp text, and I'll be more than happy to do so. Um, yeah, I'll just give you my number here if you, just in case you struggle to find it in the description section. I don't know why that would be, but so just send me a text there, WhatsApp text, and be more than happy to yeah to show you how to do the procedure. You also need to know what a diagonal matrix is. Now, a diagonal matrix is one that has zeros elsewhere and not necessarily ones along the main diagonal, but it could be anything. It could be any set of entries along the main diagonal, but it has to be ones. Sorry, it has to be zeros. It has zeros elsewhere. Okay. Yeah. So a diagonal matrix looks something like that. Okay. It has zeros everywhere outside the main diagonal. Okay. There's also the triangular matrix. Now, triangular matrix, there's a lower triangular matrix as well as an upper triangular matrix. You need to look that up. You need to know the difference between those two. And lastly, you need to know what a symmetric matrix is. And now, a symmetric matrix is one that is equal to its transpose. So if you're given an equation like that, like this, yes. So, and that's it for my summary. For my first chapter summary for this module, learners. Thank you for watching. See you next time. Cheers. I love you. Take care.